Hello, we are the machine learning and real estate team, and this is our demo for Sprint 4. These are the topics we'll talk about today. The first is data cleaning we did for the Austin permit dataset and progress we've made on our continuous integration and continuous deployment. Some research we've done on serverless, updates on our API and model, and finally our Sprint review. So first we'll talk about data cleanup. So we want to use data from multiple cities for training to create a more generalized model. And for this sprint, we worked on cleaning up the Austin data set. So we only want to use the permit types and their descriptions to feed the model. And we worked on removing any duplicates and any data that was missing, either permit types or description.
Let's talk about the CI/CD progress. Why we need to use the CI/CD? In our project, our model may be retrained regularly using the data set from different cities for the prediction model. And for the future, the image generation model, we will also need to retrain that regularly to fit our expectation, like to generate a much more precise image based on the text description. Also, our API will be modified regularly as well to improve the functionality for the image generation and the model prediction. For example, for the model prediction, for now we only support we only support using the post request to upload the JSON file to it. But in the future, we may need other functionality based on the requirement, like using the get model to get certain result from the database or something like that. So for now, there are two ways to achieve it. The one way is the first method is the common way to do so, using the GitHub action to do that. In using the GitHub action has a couple of benefits, like we don't need to concern about the deployment on the server because it will build the GitHub action will build a model, like build a whole GitHub and to run it to make sure you work and then push it. Send the code, send all the file to our remote server using the private key, but we are currently working on it, but we can't make it work because there are still a lot of problems when we try to build our model online, like on the online runner. And the second way is a much easier way. Our mentor suggests us to write a simple shellcode on the server, and this shellcode can regularly automatically check out the GitHub repo. And it is an easy way to do so because we don't need to concern about like building the model online or other error we may have. We just need to pull the code and model and everything we need to the server, and we will like run it, start a container, run it like manually. So it will take some work after we check out the model and the files to deployment. That will be manually deployment. Then we'll talk about the serverless study. So since our first prediction model is pretty much complete, we want to do some research about it. So the first thing about that is the serverless. Our model is a pretty simple model. It's just a prediction model, accepting the input JSON file or input string, and then predict the type of permit, return the type of permit to the user. So we may use the serverless to replace our current setup for the server. For now, our model is running all day on the build up test server, and it is kind of like the traditional architecture. The test server is only for our model to use, so it is a lot of waste of resource to do so because we don't need that much resource to run a simple model. So what is serverless? The serverless is a cloud native development model that allows developers to build and run application without having to manage server. Basically, it means that serverless, you don't have to worry about like how the server will run, how the server run your application. The only thing you need to concern about is how to write your application, how to make sure your application works. So the benefit of that is that it will have a lower cost, and you have a great scalability, and it'll be easy to build and deploy your application on the server. So, but there's a still server in the serverless, like the figure in the right. We can see that we still need to use the physical server to run your application, but your application will not take or like use all the resource on the one server, like the server one. They'll have 4 different applications to use the same resource, like to maximize the server utilization. So basically, it's just a shared resource with other application while they're running. So our current situation is that why we need a serverless. So the reason is that if we use the service, we don't need to worry about to configure our server, like to configure the Docker, like the image and set up everything and then run it, deploy it. And it is also have a great scalability. Like if the model will have in the future will have a much more larger usage, like one server may not be enough for the usage. So using the serverless will be easier to scale up the usage, and you are also support quick deployment updates. But on the other side, why we don't need a serverless? The build-up is currently pay a fixed fee for their server, including the test server we are currently using right now. So that means using the serverless won't save us money, because no matter our usage for the test server, we will pay that amount of money. And other than that, the model API will be called like more than 500 times per day, and the deployment for the environment takes much longer than the actual API running time. So for example, the deployment time may up to like 5 to 10 seconds, but the prediction function only need like 10 nanoseconds to return the result. And then after that, the server will create the model and like clean up everything. It will take a much more time to set up and clean up rather than the API running.
API modifications. In our last demo, we showcased how we're able to serve the model to our client through a REST API. And there are 2 reasons why we set up a REST API. The first one is because it's simple. The user can just request for the resource, and we can serve the resource to the user on an individual case. And the second, it has to do with the infrastructure of the build-up platform. So they have these microservices that they're communicating just basically through REST API. So it's easy for us to set up a REST API to just integrate into their system. And in our first API iteration, we just wanted to make sure that it worked. So we created this endpoint where we serve the model, and the user can make a post request to make an inference using the model. And in this new iterations, we made the API more robust. First, we wanted to conform to the REST API convention, so we changed the route to accept GET request rather than post request. It doesn't make sense for us to accept it as a post request on this endpoint when we're not creating new data and we're not modifying any data. We're just getting the data from the model. And additionally, we've made the API more robust by handling invalid inputs. Previously, we just expected the user to give us the inputs in the correct format, but that's not always the case. And in a case where the input is valid, the server will crash. So now in this new iteration, the inputs that are not in the specified structure, so it's like not the JSON or the JSON key, or the JSON key is not correct, or the JSON key value pairs are not correct, then it would just return an error like a code 400 back to the client. Additionally, we've made some modifications to handle empty inputs. Previously, we didn't have that mechanism. Now we can just return an error if the input is empty. So for the model update, in this sprint, we did not make any changes to our model. The reason is we're still cleaning up some data. We're still collecting data from other cities, and the data in other cities are not as clean as the Boston data set. So in some cities, we don't even have the description of the permit. So we're trying to come up with a way to collect all the data and then also sanitize it, process it in a way for us to train a more generalized model. And we're almost done with the data collection part. In the next sprint, we should have a new version of the model that is generalizable to many cities in the United States. Sprint review. So for sprint 4, we had some tasks that we wanted to complete. The first one was to make our route more robust, and we were able to add in some input error handling to be able to handle inputs that are invalid or empty. We also wanted to begin researching on our next task, which was to generate images based on the permit description. And we've looked around and also discussed how we may be able to do that. So moving forward, we have some idea on how that may be done. Our next objective was to collect and process data from different cities, and we're almost done with this. We have the Austin data set complete, and we're close to finalizing the New York and San Diego data sets. And once that's done, we're going to be able to retrain a model to be able to predict permit types from cities all across the nation. We also wanted to write a script to be able to retrieve a newly trained model and be able to upload it to a server and have that working automatically. So we're almost done with that script as well, and we should be able to complete them in the near future. So for our next sprint goals, we plan to finish the data collection part, and that will allow us to retrain the model on data from many cities across the nation. We also wanted to set up the route protection. So right now our route is publicly available to anyone, and we don't want that. We want to be able to serve the model only to authorized users. And finally, we want to finish writing the script for the automation of model retrieval after training, and also model uploading to the server to serve it. Thank you.